Alright, this is the second part of lesson 86, and it's some more non-linear systems of equations, which remember, that means that one or more of the equations is not a line. And in this particular one is going to be an example of one that doesn't factor nice and easy, and so we know what to do when we are solving a quadratic equation that doesn't factor nice and easy. We have to use our quadratic formula. The process is going to be basically the same. We've got x squared plus y squared is equal to 11, and we've got y minus x is equal to 1. So again, we have a circle, and this time, and we've got a line that passes through it, so what we're looking for are those 2 points right there where they intersect. So, first step, it's going to be the easiest thing to do. We're going to solve this line for y. We're going to get that y has the value of x plus 1, so y squared is going to have the value of x plus 1 squared, which is x squared plus 2x plus 1. If you're not sure where I came up with that trinomial, remember, go over to the side and write x plus 1 times x plus 1 and do your FOIL method, and that's what you're going to get. Now we take that and we put it back in the circle, so we get x squared plus x squared plus 2x plus 1 is equal to 11. We want it equaling 0. So we've got 2x squared plus 2x minus 10 equals 0. And we recognize very quickly that all 3 terms have a common factor of 2. So we can get rid of that common factor of 2 and have x squared plus x minus 5 equals 0. So here's where our not factoring comes in, because they're the only 2 factors of negative 5 are negative 1 and 5, or 1 and negative 5, and neither one of those adds up to 1. So we're going to have to use our quadratic formula, and our a, you remember, is 1, the coefficient of x squared. Our b is 1, the coefficient of x, and our c is negative 5. And you should be writing your quadratic formula before you ever plug anything in, because that's how we're going to get it into our memory. So we know that x is going to equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula we're going to use. So I'm going to take the a, the b, and the c and plug them into that formula. I'm going to have the opposite of 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 5 all over 2 times 1. So we'll move right over here. We got x is equal to negative 1 plus or minus the square root of 1 plus 20 over 2. So negative 1 plus or minus the square root of 21 over 2. So the 21's not going to factor. The only factor, or can't take the square root of it, excuse me. The only factors of 21 are 3 and 7, so that's not a perfect square. No perfect squares in it. But again, like in the previous problem, this is my x value. So I've got a negative 1 plus, probably that's the minus, minus, let me change that. This one is negative 1 minus the square root of 21 over 2. That's my x value, and this is negative 1 plus the square root of 21 over 2. That's my x value. As we did in the previous, we're then going to go back to our line to find out what our y value is. And we rewrote it like this. So y is going to be negative 1 plus the square root of 21 over 2 plus 1. I'm going to have to add it to there, so I need a common denominator of 2. I might as well rewrite that 1 as 2 over 2. So I got negative 1 plus 2, so my y is 1 plus the square root of 21 over 2. And that is this one up here. And I can go ahead and plug this in. I can plug this one in, but notice the only thing that's going to change is this sign right here. So this one's going to follow the same pattern, only it's going to be a minus. So it's going to be a 1 minus the square root of 21 over 2. So again, that's my 2 points of intersection. All right.